Here we're given two functions, f and g, and their equations, and asked to find the composite functions and state the domain of each. Because the domain was really where the error was occurring, that's what I'm going to focus on. So I took a screenshot of what does that mean about the domain of the composite functions f of g of x. The domain of f of g of x is the set of all numbers x in the domain of g, such that g of x is in the domain of f. So typically what I would say to kind of break that down is focus on the domain of g of x first, find its restrictions, and then find the domain of f of g of x and see if there's any further restrictions that you need to add on to the domain. So let's see how that happens in this first example. So here in this first example, we start by analyzing the domain of the inner function, which in this case is g of x. And the domain of g of x is all real numbers x, such that x is not equal to 0. That's supposed to be not equal right there, to 0. Next, we see if there's any further restrictions in the domain of the composite, which you've already determined to be this equation, 2 over 2 plus 5x. So set that denominator equal to 0, and there is a further restriction, and it's this one, that x is not equal to negative 2/5. Just notice that in order to state the domain of the entire composite function, we have to include both the restrictions of the inner function and any restrictions added by the composite, this new composite function. So let me show you at least one more of these, like this one here in part B. This time the inner function is f. So let's first consider what are any restrictions presented by this function f, and we see in the denominator x cannot equal 5. So notice that's part of the restrictions of the entire composite function. Then you find that composite function, that was done correctly, and you say, what's the domain restrictions here? Well, x cannot equal 0. Place those together, and that's the domain of the entire composite function.